In this video, we will be introducing game events. We will be first taking a look at what are the important game events that the framework is already using in the mono behaviors for the entities. Then we will see how we can instantiate new game events. And finally, we will close up by seeing game event generators that are nothing more than factories, generators of source code for custom event types that we might want to introduce in our game and are not by default provided already by the framework. Okay, so game events in the framework are implemented on the base of scriptable objects, and this is allowing us to easily share them across different game objects in our game. Moreover, also when we want to define the response that should be invoked when an event is raised, we can use game event listeners that are provided by the framework and are instead mono behaviors. So we can attach such game event listeners to our objects, to our game objects, and define always from the inspector a callback of a public function that is available in our object to be invoked in response to an event that has been raised. So if we start by taking a look at our entity, our player, we see that the first event we come across in our inspector is the entity leveled up event. Such an event has two context parameters. One is the entity core component of an entity, the entity that just leveled up, and the other one is an integer representing the new level reached. This event is fired every time an entity gains one level, and you can see that is instantiated here. By default is provided by the samples that came along with the package. So inside the folder here of the samples you have utils, event instances, and we have two folders, one for the events that have one parameter and one for the events that have two parameters. Then another very important event that we can come across is the entity spawned game event. So this is fired when an entity is instantiated in our scene, and we can use this in our game to react to the spawn of entities, to register them, to do some logic that you think is appropriate for your game. And this has just one context parameter, that is the entity core component of the entity that just spawned. Going on, we have the entity stat changed game event that is carrying around just one context parameter that is actually behind under the hood, a more complex custom data structure that is available with the framework that carries around the information about the statistic that has changed, as well as more information like the old value and the new value. And similarly, for entity attributes, we have the entity attribute changed game event that also for this one, just one context parameter, once again, a custom data structure that is carrying around inside a little more information about the attribute that changed and its old and new values. Okay, so I prepared, for the sake of this tutorial, a few scripts that will help us in showing how such events can be triggered. So, for example, we have here one grant exp component that will just, when I press this button, grant some experience to our player. Then we have also a stat modifier component that is just assigning some flat modifiers to our statistics of our player. And as we also have one attributes modifier that is just assigning flat modifiers for the attributes of our entity. Moreover, we also created some game objects that will act as the listeners that are reacting to such events when they are raised. And we have, for example, here a entity logger that has one entity core game event listener attached that will therefore react to entity spawned kind of events. And you can see, like here, that in this component we are being asked to assign to it one event, And this one is actually exactly this entity spawned event. And we have here the possibility to define the response that we want to invoke, the function that we want to invoke when such entity is raised. And here we can adjust, for example, we have here a very simple script that is defining a public method that takes an entity as an input parameter that is nothing more than the same context parameter that is being carried around by the entity spawned game event. And we are just logging the name of such game object into the console. So by assigning this one component here in the reference of the Unity action here, and here we can actually select the dynamic method invocation that I just showed you in the code, we will have such method being invoked and having the context parameter of the event being passed to the input parameter of this method that we are using for defining the reaction to the event. So in order to test this, we can, for example, for now, just disable these three other game events, these game objects. And if I press play, having our player here in the scene, and I'm loading the scene, and having the same entity leveled up here and wired it up with the game event listener attached to this game object, we should see our player being printed to the console. So we can hit on run, and as soon as the scene loads, you can see that here we have entity spawned player. Now we can quickly take a look at also the other game events, even if they are actually very similar. So here, for example, for the level up, we have one entity leveled up game event listener that is actually taking one entity level up game event that is of this type. And we are using the level up logger script that similarly this time is taking in the same input parameter, same types and number of input parameters of the game event that we want to react to. So the entity that leveled up and the new level that the entity reached, and we're logging it into the console. So once again, here what you have to do is this, and select from the level up logger the dynamic method invocation on level up. And similarly, also here for the statistics, we have once again the event responsible for notifying the change of the statistic, one logger for the statistics, and also for the attributes. So if we enter here with play, we will see obviously, okay, this is the message that our player has just spawned, and now we can try to grant him some experience. And if we give him 100 experience, we see that he reached the level 2. That is also shown here. And the current total experience actually currently is 100. And if we go on, we reach 200 current experience, but we are still at level 2. But if we give the player extra 100, we see that we are level 3 with 300 extra experience, and we get a brand new event. And now we can try to add some physical attack flat modifier to our physical attack. So if we press with this add 20 physical attack, we can see that our physical attack changed from 30 to 50. Remember that the physical attack that you see here is correct if it remains 30, because these are the base statistics. And now that we applied a modifier, is actually having 30 as base plus the 20 we just added for a total of 50 that is being managed in the memory under the hood. So we can't see here the final value, but just the base value. We can obviously increase it again and we get another event, and we can also get an event every time we decrease the physical attack up to 0. And if we continue increasing the attack, we will not get new event because currently the physical attack has a minimum value 0. Okay, so also for the attributes, we should get, we have here the lag attribute. So if we press this, we increase the lag and we get an event when the lag increases. Very well, this was is enough, I would say, for the most important events that you can find in the mono behaviors provided by the framework. And we can now take a look at how to create custom game events. For example, let's say we want to create a new game event that is raised when our player jumps. So let's put it, for example, for the sake of simplicity, just here in our assets, but remember to keep your hierarchy tidy, since you will have a lot of objects with the framework. However, here you can see that for generating events, as usual, we can go on SOAP RPG framework. We have events, and we have here game event is just the basic game event with no context parameters. Then we have here the generated. Under generated, there are all the events that are the event types that are provided by the frameworks already. Entity leveled up, entity core, attribute changed, stat changed, and int. And since we anyway want to say, well, the player just jumped, we are not interested in passing any further context parameter, so we can just use the regular base game event. And so we will call it player jumped. Now, I will not dive deep into the details of how to wire up, since we have already seen in detail how you can actually wire up events with game event listeners. So you just remember that in order to create, you can create and instantiate new game events from the context menu that you know well so far, and going under events you find the regular one, and under generated the other ones. Okay, so the last part we are left with is game event generators. So in order to create a game event generator, we can go on create once again, Super Beach framework events, and the third option is game event generator. And this class that is once again deriving from scriptable objects is allowing us to define our custom event types. They can take up to 4 context parameters, and the context parameters can either have a native C# type or a user-defined type. Obviously, if you want to go past those 4 context parameters, you can always wrap a bigger amount of parameters in a data class, and then use just that data class instead as a single parameter. And this is what is actually being done with the, for example, with the stat changed game event and the attribute changed game event. There is just one context parameter that is holding inside much more parameters. However, a good practice with game event generators is to define one game event generator for each context of events. So, for example, one game event generators could be used, for example, for defining all the event types that are related to the player or the entity's movement. So, for example, moving events, something like this. And here you can choose the menu base path. So in the context menu that you have when you right click on your assets and go on Super Beach framework, this is the base route that is defined in general in the here in the game event generators, but you can also customize it and in case decide to choose a different path if you want in your own game. By default, it is Super RPG framework, events, and generating, and that's why you see already these ones here, because these have also been generated through game events generators. And the base save location is where this game event generator will save the C# generated source code that defines the new game event types that you just added. So This is not actually the save location for any of the instances of the events, but is rather the save location for the scripts that the events you will be defining will be based upon. For this, in this case, for example, we may want to say, yeah, assets can be fine as we did for this, like, but in a real world scenario, you would like to choose more carefully here a base location, like scripts, and then here maybe we can, for example, already do this, events, and then we say assets slash scripts slash events. Very well. Now, if we press add new event, we have here a new event definition. And for example, the first could be entity file. An entity file with x Newton force. So, for example, we want to define an event that will communicate with how much newtons of force an entity fell. This can be, for example, a float. So we can go here and select, yes, we want a native. First of all, we want to notify obviously the entity that fell. And in this case, we have to grab our entity core script that can be found under SoapRPG framework, runtime, and here we have entity core. And the second parameter, that is the float defining the amount of force that the entity fell with, will be a native in float. Very well, now we have our new event. We have here a warning that says the following events have been added but not generated yet, entity fell, so we can generate the game events, and you will see that here is compiling the scripts because we are adding a new script to our assets. And oh, actually I made a mistake here, there was a typo, but as you can see here, scripts, events, generated events, moving event is the folder of the that specific game event generator. And then you can have you have both the game event listeners C# script, so that are inheriting from the mono behavior, so that you can attach this listener to your game objects to react to entity file events, and also the entity file game event that now we can use it if we want. For example, here we can go and create SoapRPG framework events generated, and we see that now we have entity file game event. For example, this will be friendly unit fell, the event that we will be using for notifying when a friendly unit fell, but not an enemy, for example. But this is just for the sake of example. It's up to you to define if you use a single game event for all the entities or a single one for the player. It's up to you to define how to use them. However, there is one important thing to say, that we have to pay attention, as this info box says, when we are moving the generated C# scripts of our new game event types, or when we are renaming the C# scripts of the generated game event types. This because when we press generate game events, if we moved the previously created scripts, for example, these ones for the entity file game event, in another location, and then we press generate game events again, or similarly, if we instead change here the base save location to something else and right away press this button, the tool will see that is not able to find the already generated events anymore in the location that is mentioned here, and he will generate new ones and delete the old ones. So this will cause, if you have already instantiated, maybe as we did with this game event, a lot of events and shared these events across your project, you will have broken references since the event will not be using anymore any script. So I can show you, for example, let's say that event, we can change the path, but say events temp. And now I hit generate game events. You see that is recompiling because he erased the old location and he generated then a new here. And here now our player, our friendly unit file, you can see that has not anymore any monoscript script associated. So what we can do is, well, we can now reassign this, but this is not comfortable in the case we have many instantiated events. Could be like cumbersome to re-reference everything. So the very first advice I would give you is before touching regenerating game event types, be sure to make either a backup of your project or make a commit with the version control system that you are using so that you're sure that you can roll back the changes and you have a checkpoint of your project and you do not lose everything. However, there is a safe way to rename, to move the location. Like if we now, for example, let's say the idea is to take like the generated events folder. If you have to move just like this, we can move it inside events from the Unity editor, and after this we can go here, change the base save location so that it matches the current location. And if we now can see that here obviously we still have the valid reference, and if we now hit generate game events, no compilation will run. He will say, yeah, okay, I generated, but actually he already has the references just where he was expecting for, so our friendly unit file event is still valid and is correctly referencing the script. And similarly, also if you have to rename an event name, if we now change this name and generate game events, these scripts will be erased and will be created anew with the new name. And once again, this one will have a broken reference. So also in this case, if we want to rename the events, we have to first go on or with any IDE like Rider or Visual Studio Code or whatever you're using and rename from there, or you can also proceed by this. So for example, on entity file, let's say we want to rename it like this, so we rename 1. Obviously, we're going through some recompilation because we're changing the name of the scripts. Also here on entity file game event listener. And once we have made this change, we can then go here and change also this one. Now, if we generate, it will cache the new information and we will have the friendly unit file with no broken reference. So it is important to remind that if you have to change the base save location or rename the events, it's very important actually to first apply the changes in the Unity editor and only then reflect the changes here on this in custom inspector. However, you can also find this one disclaimer in the documentation. So on the package documentation, you can go to docs, then workflows, and down here in the table of contents, there is this game event generators, and you will see that there is one big warning panel that says to what pay attention to when renaming or moving generated C# scripts for the new game event types that you define through game event generators, and how to safely move them or rename them. And with this is all what we have seen. So we went both from the game events that are used by the framework, seeing also what game event types are already predefined by the framework. Then we have seen how to generate new game events. And finally, we covered how to generate new game event types through game event generators.